Alright guys, so the goals of this video are to look into defining our definite integrals. Alright, we're going to define our definite integrals here. And we are going to kind of break apart what the integral actually looks like. So we just wrapped up Riemann sums in our last video. And now we're going to start diving into the main way, I guess, if you will, as to how do we actually evaluate integrals. All right, so we're going to break it apart, the definite integral first. Second part of our goal in this video is to define how to take the integral of a constant. I'm going to take a couple examples of taking the integral of a constant value. Start off very basic, nothing too crazy here. So let's break it apart. So first and foremost, what you see on this screen is the integral. And so what we have here is the integral sign to my left. All right, so to the left on over here, we have our integral sign. Following through, we have what we call the integrand. The integrand is our f of x. So that function f of x, we call the integrand. It's just basically what function are you taking the integral of. That is the definition of our integrand. Your dx, don't forget that your dx, that is our differential. All right, differential basically just is our variable of integration. So kind of how for derivatives we had dy dx, we had take the derivative of y in regards to x. Kind of the same concept here. And then finally, we have our upper and our lower limit. So we have the lower limit a, the upper limit b, and all together this is the integral of f from a to b. All right, so let's kind of dive a little bit deeper into the definition of how do we go ahead and start off basic and find the integral of a constant value, okay? So let's say we have a function, f of x, and it is a constant, so we're going to give it a value or a denotation of c. And let's go ahead and say that it is over the interval from a, to keep it consistent with some things that we've been talking about. We would write this as the integral of a from a to b of f of x dx. Well, since f of x is the constant, we can write that as the integral from a to b of c, our constant, dx. So what we're going to find out here in a sec is that when we take the integral of a constant, we actually are going to basically be saying that this all equals the constant multiplied by the difference of b minus a. All right, because think about what this really means. This is really just kind of finding the area under a straight line. That's really all this is actually going to be, is what it's kind of coming down to here. Let's take a look here at a basic example to start some things on off with. So let's say, for instance, we are given the integral from negative 2 to positive 1, and it's just the constant of 5. And it just, the goal is to evaluate the integral. We want to evaluate this integral here, okay? So following its footsteps of what we see right above, this would equal to 5 times plus 2. Well, 1 plus 2 is 3, so this has a value of 15. So not too bad to start off with. All right, pretty basic, pretty simple when we're starting to find our integrals of constants. So it's, again, not too crazy. Let's just try one more just for the fun of it. Let's say we have from 0 to 3 of 7. All right, so once again, we would take 7 minus a. So 3 minus 0 in this case, and then 3 minus 0, of course, is 3 times 7. Gives us 21. All right, so pretty basic into giving a shot at cells. All right, so that kind of wraps up this video. We defined the integral. We went ahead and defined what it means to take the integral of a constant. And then we did a couple examples to find some integrals of constants. All right, on to the next video, we'll look into a little bit deeper meaning of area.